Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is from Warp Mechanics. We have the CTO of the company, Judd. Josh, welcome to the show today.
Thanks for having me.
Well, great, Josh. I wanted to bring you on to talk about your MicroPod, the Kickstarter project. But first, let's start with Warp Mechanics. Who is Warp Mechanics, and who do you help?
Warp Mechanics was a company created in 2010 with the objective of taking HPC technologies and bringing them into other markets. So most of our customers historically have been media and entertainment companies. Probably 90% or so of the stuff we've sold historically has gone into Hollywood movie studios or gaming companies that do massive multiplayer online role-playing games and things like that. Because we notice there's a whole lot of technologies used in supercomputing that the big data guys or the big Internet 2 firms really need the same kind of structural solutions. But they don't have the army of PhDs running around to install and manage them. So we wanted to make it a little bit easier to deploy these things. And that's actually where the MicroPod concept came from, given that we'd already done a lot of this work to make HPC technologies easier to deploy. We thought, well, let's take it to the nth degree and make it possible for home users to get access to the same kind of technology. This is basically what I'm going to talk about today. What is it that we're trying to solve here? What is the solution that we're proposing for it? What would you do with it? Assuming that we finish building this thing, what's the point of it for home users to have? I personally wouldn't work on this project unless there were some sort of social good for it. So from the standpoint of the world at large, why should people care about this thing? Also, why we think we're the right people to actually do this work and what we're asking people to do to help us get it done. All right, what's the basic problem that we're working on here? As most of your listeners probably already know, all of the big science and big engineering that's happening needs a supercomputer to work. You really can't try to cure cancer on your laptop. you need a parallel computer to work on that sort of thing. Same thing with anything in aerospace or engineering of a new type of suspension bridge or whatever. Everything is using parallel computers these days. The problem is colleges are not producing HPC professionals. I'm not really finding entry-level HPC guys coming out of the college system. To the extent that you get people like that, it's almost like an accident. They happened to go to a college that has a supercomputing center, and they happened to get a job working on it, to pay some of their, costs while going through school. Particularly people entering college aren't entering college with any HPC skills. And if you don't already have access to a supercomputer, how would you learn even if you were an interested home nerd? Like if you're a college student or a high school student and you just want to get some experience with parallel programming or systems administration, you would have to talk somebody into letting you play around with their $10 million supercomputer in order to learn how one works. So it's a very, very high barrier to entry for people to learn how to admin one of these things. So the MicroPod project is a proposal for downloadable images that have all of the parallel computer elements pre-built. Again, I think your listener demographic is already generally familiar with parallel computers. So the compute node, the cluster control node, the object storage server, these sort of elements would each be pre-built as virtual machine images and pre-built as DD images for hard drives that you can just flash onto a hard drive to get it running if you want to do it on physical hardware. We're pretty good at doing this at work because that's actually how we build systems today. We flash these images onto SSDs inside, white box servers or OEM servers to create an actual supercomputer. So really all we're proposing doing is taking the work we've already done and porting it for commodity hardware and virtualized hardware. Now, once this solution exists, it can be used as a training tool. It can be used as a training tool for free by college instructors. It can be used by personal interest. If you are a high school student and you want to know what parallel programming is all about, you can just download it and start running it right away. So because we're going to give away a whole bunch of our own intellectual property and spend a bunch of our staff time porting it, we're having to figure out how to fund the project. Since Warp is a for-profit company and this is not a profitable project, we're looking at creative mechanisms to get the staff time funded. So a little more detail in what a MicroPod is. Turnkey is important. Open source is important. Turnkey, we're trying to make it take 10 minutes or less for you to get one of these things running as a virtual environment. Basically, you should just have to download the images and stick them onto, a VMware environment you've already got, or a KVM environment that you've already got, or upload them to a cloud server, hit go, essentially, and have it already work. But this wouldn't be terribly useful without documentation. It turns out that the documentation for supercomputers is a little bit lacking. Well, I mean, there's a whole lot of documentation out there, but nothing that really tells a home user how to turn one of these things on. That's not really who the documentation is pointed at. So we've figured in order to make this actually useful, we'd have to have a tech writer work for a few months to write a cookbook, if you will, written in human consumable terms that tells people how to actually get one of these things going. So the whole point is to make it easy for somebody who isn't already a parallel computing expert to get started. So what we're going to do is donate all of our existing relevant code and practices to the project, but then have some of our staff strip out all the stuff that's like way too much information for a home user, strip out any code that only applies to full-scale HPC systems, and turn it into something that's just what you need to get started as a parallel programming student, etc. Excuse me. I apologize to your listeners for occasionally coughing. I'm like a lot of people, I'm getting over the flu. Seems to be going around these days. Okay. Once we get it done, everything, including the documentation, including any original work we do, will be released as GPL. We will only, at least to the extent that we're able to control and vet this, we will only use freeware packages as well. We will make sure we don't include anything that's proprietary. If there are interested partners who want to contribute a freeware version of a proprietary thing, that's okay. But we're not using this as a mechanism of advertising commercial software to people. So it's only going to be based on free software. So in order to get that done, we've looked at a couple of different outside-the-box ways of funding the headcount to do this. First thing we're trying is a Kickstarter project, but we only gave that 2 weeks because, I either have to tell the programmers to start working on this or not. So, getting a Kickstarter project funded in 2 weeks is kind of a long shot. So, mostly we think this is going to end up getting funded by having one of our existing customers work with us on a grant. In the HPC space, there's a lot of public money or grant money to be had. So probably it'll end up being funded by an interested customer who wants to help get this done. So this shows a couple of diagrams. One shows the wiring diagram of a physical MicroPod. The other shows how it would be implemented as virtual machine images. Excuse me. Again, one way or another, you get the structure of a parallel computer without having to actually work on a multi-million-dollar parallel computer. So, is not. This is not an actual supercomputer. It's not going to go fast. So, it'll go a lot faster than your laptop, but it'll go a lot slower than an actual supercomputer. So we're trying to make sure people understand this isn't good for performance tuning. It isn't good for actually running, engineering simulations or whatever. But there's a whole lot of aspects to parallel programming and systems administration that you really can't do unless you've got a network of nodes hooked up to a network of storage. Like if you want to learn how to administer a Lustre storage environment, trying to do that without Lustre is kind of an uphill battle. So this gives you an environment that has the complete structure of a parallel computer where you can try out your code or try out your sysadmin techniques without having to break somebody's multi-million-dollar supercomputer. So what would you do with one? Well, aside from learning, which is a pretty big one, you could use it as a software development framework, even if you do have a full-scale supercomputer. The more time you spend using your multi-million-dollar system as a code development system, the less time it has to run the actual software. So if we can give you something that you can run in the cloud or run, in a simulated environment, that's a use even to people who have full-scale computers. We also want there to be a larger ecosystem of professional parallel developers to increase the number of applications available for HPC systems. There are a whole lot of applications in the commercial space that could benefit from running on HPC hardware. But a lot of the companies that make these applications don't have supercomputers, don't have access to them. So by making MicroPods available for commercial software developers, I think will increase the number of parallel applications that exist in the world, which is good for HPC overall. But there's also a lot of things that a home user could do if they built one of these things and stuck it under their desk. You could build your own multiplayer online game. You could make a video repository server powerful enough to serve an entire city block. So there are practical applications where people could use the parallel processing aspect at home for something useful. But honestly, the last bullet is the one that sold me on the project, which is that I actually like this nerdy stuff. And to me, the fact that I actually have a supercomputer in my condo is just, fun. Now, I'm going to invest in this kind of project, I want to know that there's a social benefit of it. It's not just, something that's producing more free software in the world. And normally I'd spend some time on this slide, but again, I think your listener demographic is already aware of a lot of this. But briefly, supercomputers are behind basically all of the really interesting science and engineering happening today. It's not just the big-ticket items like the Higgs boson and whatnot. Lawrence Livermore is using this to develop green energy systems. Almost all of the big medical and healthcare research is taking place on these systems. So if we produce more high-performance computing experts, we can produce more HPC systems, which will make scientific research move faster, and I'm all for it. The reason we think we're the right people to do this, well, to put it bluntly, we've already done it. I mean, we've already taken HPC code and turned it into a turnkey system. We developed it as a petapod system. So the MicroPod is basically just a downscaling of our petapod. This just kind of shows what the petapod currently looks like, and if you kind of flip back and forth between you shouldn't do this, but if a viewer in their own time wanted to flip back and forth between slides 5 and slide 9, you can see how the MicroPod architecture is structurally the same as our petapod design. So it's really just porting software, removing any proprietary elements, and creating easy-to-use documentation. So if any of your listeners think that this sounds like a good goal, if they would like this project to exist, there's three different ways they can help us get it done. One is by logging into the Kickstarter project and pledging to buy a t-shirt or something like that. Note for those who are new to Kickstarter, we actually don't get any money from the Kickstarter project. Like if you buy a t-shirt or something, Warp Mechanics doesn't actually get any money from that unless we actually produce the deliverable. And we've only requested enough money on the Kickstarter project to do the deliverable. So even though we are a for-profit company, this is not a for-profit project. So if you think this is a good idea, you can forward the Kickstarter link to any of your nerdy friends who might also think it would be a good idea. And regardless of whether you want to look at the Kickstarter or not, we are going to try to get this funded via grants or some other method. So please go ahead and shoot an email to updates@micropodhpc.com with subscribe in the subject line. And we'll keep you up to date on the project status and let you know how we ultimately get it built. And that's pretty much it for today.
So Josh, we've seen a couple examples like this of what I'm calling crowdsourced HPC, Kickstarter projects around high-performance computing. Are you familiar with the Parallella project where they're going to build this ARM-based board to bring parallel computing to the people?
Yeah. So I am definitely in support of that project. I think it's a great idea. It doesn't solve the same problem we're trying to solve in that what you get out of that project is a new piece of hardware. And to me, the distinction is in order to really learn how to administer a parallel system or program for a parallel system, you need to focus on the architecture of a parallel system, which is a network of full-scale systems, each of which has some number of multi-core chips. So what you're getting out of Parallella is a chip that's got more cores on it, which is a good idea. But if you wanted to build a real supercomputer out of Parallella, you would need thousands of systems, each of which might have dozens of Parallellas in them. And learning how to do application programming or administration of a full-scale system like that is still a fundamentally different animal. And that's really the problem we're trying to attack. How do you deal with that parallel system structure?
So kind of a wrap-up question here, Josh. If you get this MicroPod funded or you find a way to get it going, in any case, where does it go from here?
Well, for us, it essentially becomes our community project, right? Like a lot of big companies will have, the Fedora Community Edition versus the Red Hat Enterprise Linux commercial edition. We'd ultimately like to continue devoting staff time to maintaining the MicroPod as a community edition of our Petapod operating system. So where I'd ultimately like it to go is I'd like it to even get ahead of our commercial platform in capability.
Well, terrific. Well, Josh Judd, I want to thank you once again for coming on the show today.
Great, thanks.
Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing.